Hello and welcome. My name is Yuri, and I am an engineer working on the Cosmos DB emulator here at Microsoft. I want to share with you one of the features we've been working on for this release. Our goal here was to instrument the emulator with comprehensive telemetry that includes traces, metrics, and logs. Telemetry is crucial because it gives both users and developers deep visibility into emulator operations, making it much easier to identify issues, performance bottlenecks, and usage patterns. This empowers teams to gain actionable insights and ultimately improves reliability and user experience. To achieve this, we chose OpenTelemetry, the leading open source observability framework. For our exporters, we chose OTLP, or the OpenTelemetry protocol, which is a vendor-neutral protocol supported by many backends such as Jaeger and Prometheus, which we will show off in this demo. This image now also ships with the OpenTelemetry collector, a service that receives, processes, and exports telemetry data from instrumented applications such as the Cosmos DB emulator. With this update, the emulator now emits rich telemetry data using OTLP so that you can plug in your favorite observability stack and monitor, debug, and optimize your Cosmos DB workloads with the tools you already use. With this new feature, of course, comes some new flags that you can use to control what is being emitted by the emulator. Here I ran the emulator using the help option. This will show the new flags that we've added: enable OTLP, enable telemetry, and enable console. By default, the enable OTLP flag is set to false. All telemetry, whether it be logs, metrics, or traces, is sent using this protocol when it is enabled. Set this to true if you wish to collect telemetry from your workloads. The enable console flag toggles the console exporter. Whether you are running the emulator in Docker Desktop or in a terminal, it will print all telemetry to standard output. The Enable Telemetry flag will allow some metrics to be collected by Azure Application Insights. For this demonstration, we will set all of these to true and I will run the program. For this demonstration, I am using Docker Compose to stand up a Jaeger container for traces and a Prometheus container for metrics. An example of this setup can be found in the README. We'll start with the console exporter. I have generated some traces by making some calls to the emulator, and as you can see, all telemetry is being sent to standard out here. We have examples of metrics being sent to standard out with their values, and we also have examples of traces being sent to standard out with all of their parent traces and related tags. We won't go too deep into the details of these traces, as we will see them in more detail in Jaeger, and we will also see the metrics in more detail in Prometheus. Nonetheless, the console exporter can be helpful for quick, rough debugging or troubleshooting of issues related to telemetry itself. This is Jaeger, a popular tool for visualizing traces. To get to the traces that we care about, we will select our service from the drop-down here and click Find Traces. We'll now scroll down to the first request that I made, which was to create a database. Here we'll give you an idea of how much time the emulator is spending doing what things. If we drill down into one of the child spans, we can see a tag section, which gives us a lot of information about the request itself, such as the operation type and the resource type and the HTTP method, just to name a few. Now let's look at a more interesting trace. This trace was created by me sending a request to the emulator to query a document by its ID. As you can see here, this is a query operation, and like I said, the resource type is document. And here we actually get, on query operations, we actually get the query text. So this will be helpful for debugging purposes so that you can see what actual query is being run and what it's being translated to. Now let's take a look at Prometheus, a popular tool used to visualize metrics. If we click on this drop down here and go to Explore Metrics, we can see some of the metrics that are emitted by the emulator. If we take a look at the query metric, we can see that it has some useful labels here. The query type label shows us the types of queries or operations that are being performed. We also have some default labels that will show up on each metric, such as the emulator ID, the job, the service name, and the service namespace. Let's take a look at the request metric. This metric has labels to show us the status code of each request. Since each request that I made to the emulator was successful, we see 200 and 201 values for the status code label. Now let's try adding this query metric to our Prometheus query. Once we hit execute, it gives us a table of counts. These counts correspond to each unique combination of metric and labels. We can also graph this relationship for a different visualization. For fun, let's also see what this request metric looks like when we query it with Prometheus. Again, we produce a table that shows the unique combinations of metrics and labels. Here you can see that 5 times a status code of 200 was returned, and the other 5 times a status code of 201 was returned. Again, like with the other metric, we can graph this metric as well. Some final things to note is that users can override the default OpenTelemetry configuration. These instructions are included in the README document that goes along with this feature announcement. To recap, the Cosmos DB emulator now supports OpenTelemetry out of the box. Users can export traces, metrics, and logs to any OTLP compatible backend, which makes it easier to monitor, debug, and optimize Cosmos DB workloads in any environment. Try it out. Check out the documentation for more details. Please let us know your feedback, and thank you for watching.